This is chunk 2, or the second half of experimental probability. In the first one, they gave us the experimental probability, and then we were asked to estimate how many occurrences we would have for a certain number. In this one, what it's asking us to do in the first place is to find the experimental probability. So we're going to be doing exactly the same. Let's have a look at this example. I'm going to read it out. A box contains an unknown number of coloured balls, and a ball is drawn from the box and then replaced. The procedure is carried out 100 times. So what we're going to do in the first place is write down 100 on the bottom of our fraction, because that is the number of times that we did the trial. And the colour of the ball drawn is recorded each time. 25 red balls were recorded. So let's put the 25 on top. Now, the question is asking me first, what is the experimental probability for selecting a red ball? Well, that is simply what I've got up here. So my probability is going to be equal to 25 out of 100. Put that in my calculator as a fraction, push equals, and it will come up as a quarter. So I am done with that first one. Next one, find the expected number of red balls if the box contained 500 balls in total. So there's 500 balls in total. I'm expecting that once for every 4 balls I pull out, I am going to get a red one. So I am going to have, first of all, again, my total is going to be here, 500, and then I'm going to multiply that by my experimental probability, 1 on 4. You can put that into your calculator and you will find that that answer is 125. Now this is all we need to do for these series of questions. Let's have a quick look at the rest of the questions we are doing today. All right, so we've already done, so I have clicked on the wrong one. We've already done the first, well, we've got them here, 5. So we're starting off here. This is our second chunk. So what I might do is just change colour of my pen, and we'll go for purple pen. So chunk 2. All right, so 6, question 6 says, a bag contains an unknown number of counters, and a counter is selected from the bag and then replaced. The procedure is carried out 100 times. So in the first instance, you will be putting 100 on the bottom of your fraction. And the colour of the counters is recorded each time. 60 of the counters drawn were blue. So 60 out of 100 were blue. Now the questions are, the first thing it's asking me for the experimental probability of selecting a blue counter. Well, that is just this thing here. So you can just write that in your book. Again, write it down as a fraction, put it in your calculator on the equal sign, and come up with the probability, the simplified probability on the right-hand side. So 60 on 100 will go here, in the first, above the first line, and then you're going to put equal and put down the second one. Now what you're going to do is you're going to find the expected number of blue counters if the bag contained 100, or 2 is asking you for 200, or in the third one it's asking you for is 600. So once again in your book, you are going to write down 600 times the fraction, or 100 times the fraction you found for the first one, then 200 times it, then 600 times it. Question 7, the last question, which is question 7 here. Experiment involving 200 people chosen at random. Let's put 200 on the bottom of our fraction. 175 people said that they owned a home computer. So 175 own a home computer. Experimental probability, once again, you are simply writing down what we've got on the top there. Then put an equal sign in, write down, put in your calculator, 175 over 200, push equal, write the answer down to the right-hand side, so we've simplified it. And then your last one, you are going to be, and again, this time around, I'm just going to read it out and not write the numbers down. The first one is 400 people. How many people are expected? The next one is 5,000 people. How many people can be expected? And the last one is 40 people. how many people can be expected to own a home computer.